Mesosphere. Mesos is kind of the scheduler of this data center operating system, which communicates out with the agents. There's a handful of services that run on top of that Mesos base layer, which are used to expose your application. So getting a little bit more detailed, the way this is set up is the physical or virtual machines that you're running your resources on have the Mesos agent installed. They communicate with a Mesos master via 2 channels, via a ZooKeeper service, which is a network key value service, and then a REST API. Mesos communicates with these frameworks, which have parallels to services within your normal operating system, like your cron schedule, which would be Chronos in DCOS language, or like your environment variable, which would be etcd, or Marathon, which would be your services definitions. And then inside of these different frameworks or services, you set up your own applications. So a common deployment in something like this would be, I have written my web application, which lives in Git. It is built into a Docker container. It's baked into a Docker container and put into a registry. I then have a Marathon job definition, Marathon being the Mesos framework, which defines how many of these Docker containers I want running at all times, and what port it should be exposing, how much memory and storage and network capacity the job needs, and it would make sure that that stays running all the time. So as long as the agents, the Mesos agents that are participating in my cluster are well dispersed, if a rack goes down, Marathon will detect that, move these Docker containers off onto other agents, spin them back up, and make sure that we still have as many as we've defined. So lots of new services in here that we're mentioning. Gets a little confusing, so we'll try and reiterate the definitions and what a lot of these services do as we go through. A brief primer on initial access. This isn't a talk on web application exploitation, but it is kind of the first step into getting the entire DCOS cluster owned. So we'll do a quick demo on what the UI looks like and how that initial access might work. Sweet. So when you first spin up a DCOS cluster, there is a cloud formation.
You gotta take this out of the presentation mode. And then we go over and then we do big, and then they should be able to see it.
Okay, so when you first set up a DCOS cluster, you can do that via CloudFormation, or you can go out through and set it up on one of your own boxes. Hooked up with Google authentication, so you set that all up. First sign in, and you'll see a dashboard here that shows all of the resources that are being contributed to your cluster by your agents. So CPU, memory, disk, services health. Right now, this is a brand new, fresh deployment. So there's no services in there. So all of the resources are available. Jumping over into services, nothing here. I think we do click through the deployments, nothing there as well. Jobs, this is one-off. This is your cron, basically. Virtual networks, you can set up some amount of network segmentation within DCOS. Nodes, these are agents that are participating in your cluster. Right here, we have 6 agents set up, all of which are healthy. DCOS also has a universe, which is the DCOS package manager. So just like Ubuntu has apt-get and Red Hat and Fedora boxes have RPM, you can, or Yum, excuse me. There's a package manager for DCOS, so rather than having to build these services from the ground up, you can connect to an existing universe repository and deploy commonly used applications like Jenkins or Artifactory into your cluster. You can also set up custom packages, which you may use across a bunch of clusters. Then your normal configuration for commonly used services. So we've mentioned Marathon a couple times. That is present in pretty much every DCOS deployment. if we were to create a new service from a Docker container that we had already created, we would go through this dialog. I'm going to spin this one a little bit further. Okay, so here we're creating a new. Okay, deploying an application via the universe, and we'll come over here and create a new service. All right, so creating a new service from a container that we've already spun up. Frank FOUO is Bryce's Docker registry. So if you want to play around there's some fun things. We set the network that's set up. We're just using host networking here for a bridge networking for a Docker container, and we're exposing port 80 from the container. I believe it's running Nginx or Apache 2 or something like that. We tell it which agent roles we want our job running on. Since we want to make this publicly accessible, we need to make sure that we deploy it onto agents that are public, slaves that are public. And just like that, Marathon spins up the instance. If we jump in here, we can tell which host it is running on. So it landed on that .4.247. And the deployment that we used, it basically chooses a random host port. So we defined inside of the container that we want to expose port 80, but outside of the container, if you want to access that service, it's mapping port 5360 to that. So if we're not on inside of the container, the service that we want is on port 5360. So we can browse to that port now that the agent is running our service. And there's our very dumb little web application. Again, we didn't want to focus too much on the initial access part. So there's a very vulnerable eval.php. I bet you couldn't figure out how to exploit that script in here, or web page. Pretty straightforward PHP code injection, which we can use to upload a web shell, which is that weavly.php. Weavly.php is a pretty cool small web shell. You upload a PHP script, PHP page, and then you set up a password for it. And using that password, it's authenticated, it's encrypted communications, it's interactive once you set it up on your side. Yeah, pretty cool little web shell. So with that presence, you can call your system info, you can run your normal commands, you can curl down another payload and run it, which is, I believe, where I'm passing off to Bryce.
Okay, great. Thanks, Scott. You get this. So yeah, Weavly, it's a cool modular web shell. It dynamically will load up additional modules from the operator side to the remote target side and keep those in memory on the target. So you just really need this small Weavly shell that can load up additional code. And then as you can see, we're in this video, we're kind of interacting with the remote target through the web shell. We check to see who we're running as. We're running as Apache. The www data user is Apache. And then we're checking to see what dependencies are on the remote target. So we can see Perl's there, but if we witch Python, we will be disappointed. So the reason for this is containers only really are supposed to only contain the dependencies they need for the service they are hosting. So if you're running Apache, you don't really need Python installed on your remote target. So you're going to run into very stripped down environments if you're exploiting into a containerized environment, heavy containerized environments. So solution for missing dependencies, if your toolkit is dependent on Python or something like that, would be just to bundle the stuff up, right? So you want to bundle up your attacking toolkit. And here, all the modules that we've written and we're releasing are built around the EmPyre framework. So this was spelled EmPyre with a Y, but now with the new 2.0 beta, it's all kind of been rolled into one code base, both the Python and PowerShell. So I wrote a stager, a module, and I'll show you in a minute, that will actually package this all up for you using PyInstaller into one ELF binary. So PyInstaller enables you to convert a Python script into an ELF binary. So I've automated that process through the script, through the stager. And generally speaking, containers, when they're inside the cluster, they're going to be, getting spun up, performing tasks, and then they're going to be periodically being refreshed. So they're going to need to know how to talk to other services, which are also inside the cluster. So the way most people in a Mesos or DCOS-like environment are doing service discovery is through this service called Mesos DNS. So this is actually different than the classic DNS that you guys are all probably very acquainted with. This is actually an HTTP REST API that can be queried via these web services and return back information, which is similar to DNS, but containing like ports, protocols, other things can be contained in there. So I'll just do a little short demo of this stuff, the modules that I've written to help query these services and automate this process a little bit more so we can start to get more of a solid understanding of how this works. So EmPyre kind of has an operator side, the hacker side. This is what it looks like when you boot it up. These are using the new 2.0 beta, which merges the PowerShell and Python into one solid framework. This stuff is open source, and I'm going to push the new modules that are in the videos today to the repo probably tonight. So when you start up EmPyre, it's got the prompt kind of like a Metasploit-like environment, if any of you use Metasploit or Interpreter. Then you want to set up your listener. So this is a port that's going to be listening on the attacker side for the callback or connection from the agent that we're going to generate, which is the agent here is going to be that packed up ELF binary using PyInstaller. So we created a listener using HTTP. Listeners can have different protocols. We set the settings of it. This probably looks very similar to Metasploit if you ever used Metasploit or any frameworks like that. And then we execute to start listening on port 80 on the attacker side. So attacker side, we're now listening on port 80 using EmPyre. Now we need to create the ELF binary, which we're going to move to the target and execute to get the callback. So I wrote this stager. So we're going to use stager PyInstaller or multi/launcher. All right, come on, quicker. Okay, so this is what you would normally do. You would do this normal multi-launcher, and what this does is it makes like a one-liner, like a command you just copy and paste on the target and execute. The problem with that in our scenario is Python's not on the target, right? Because it's not inside the container, so we need to package it up. So language Python. All right, I'm just going to let it run its course. So you check all your info and execute. So that's the one-liner normally you would execute on the target. So it's actually kind of slick. So it takes, it echoes the Python code through a pipe to Python. And that way, if someone looks at the process list on the remote target, they actually won't see any of the echo content. They'll just see a Python running on the remote target. And so that way, you can kind of obfuscate what's happening inside of the Python process. So that was a pretty slick technique that the guys who created this framework came up with. So now we're doing it again, but we're doing it with the PyInstaller one that's going to build our ELF binary. So I wrote this stager, and all the modules on the operator side are written in Python. So if you guys wanted to extend out, I have this great idea of something an attacker could do, you could look at somebody else's Python modules, create a new one, kind of like Metasploit, and just expand the framework. It's really easy. So once it's executed, now it's created this ELF binary in the attacker's temp folder. And we're in /temp now, and that's our ELF binary there called EmPyre. I included the spec file and other supporting files in case you want to do some customization. But now we're going to move that file onto the remote target using the Weavly web shell access. So Weavly makes this really easy. It has several commands to upload, download files, or even wget a file from a web server. So for web shell operations or Apache operations, it's pretty convenient. And also, it's really convenient for extracting data from databases, which the web server may be able to access in like a DB exportable format. So I've used that on pen tests in the past, and that's really saved me a lot of time. So just starting up a little web server here to serve up the ELF binary on the attacker side. And that's going to be on port 8000. And then switching over to the Weavly web shell. We are going to interact with the remote target and wget the binary, basically, from the web server, and then execute it to get interactive on the box using EmPyre. Okay. All right, so just fast forwarding a little bit, we use the file download to do it. We set it as executable, and we executed it. We can see on the attacker side, it pulled the binary. And then if we switch over to EmPyre, we can see we're now interactive on the target. All right, come on, buddy. All right, so we can see we got a new agent in EmPyre, and now we can go interact with that. Interact, and we just run the ID command. We can see now we're running interactively as Apache. Okay, so the big difference here is that we can more fully execute commands on the target now. We can read and edit files easier, things like that. And also, we have like available all the modules which have been built out for doing reconnaissance in the DCOS Mesos environment. So if you want to use a module, you just use the use module command inside of EmPyre. And then I just wrote a quick module called get host by name that just does normal DNS resolutions. So some of the services you can find the IP they're associated with just by looking up. Most of the Mesos environments have a top level domain, which is resolvable by any container inside the environment, which is usually .mesos. So if you do like marathon.mesos, or you do chronos.mesos, or you do master.mesos, you can actually figure out what IPs things are on. The problem is services are going to get spun up on random high ports as containers come up and down. So you're really going to want the port information as well for the service, unless you want to do massive port scanning. So Mesos DNS is really the best way to get the port information. So I'm going to go ahead and show that. All right, here we go. Okay, so I wrote this module. It's called HTTP REST API. It just basically will allow you to set these settings that you see before you, hopefully, yeah. So, and interact with any RESTful HTTP API. So you can set a get, post, delete, other values for the request method. And then you can set, the domain you want to connect to, which is master.mesos, because we're inside the containerized environment here. And then you can set the path, which is kind of how you, query a RESTful API. And then it'll just display the information back to the screen. So kind of cool thing. The APIs for a lot of services, they have some documentation. So here we can see the documentation for Mesos DNS. But really, you want to dig deeper. So in doing just a little bit of research, by digging through because most of this stuff is open source, right? So through digging through the source code, I was able to find additional RESTful API calls that you can make. So and I found this one specifically called enumerate. So if you call v1 enumerate, or v1 enumerate, it will actually give you back like a zone transfer equivalent, like all the information about all the services, all the ports that are inside of it. And, it's probably just they haven't updated their documentation yet, but, it's not really in the documentation. So, but I'm sure, a lot of this stuff is pretty emerging technology. So the documentation is always lagging behind the code. So from here, we just set that path, and then we execute using this RESTful API module, and then we'll get a full list of all the services and ports inside of the cluster. Now, there's a few other ways you can get the same data. If, for example, this service isn't available, you can actually go directly to the Mesos agents or the Mesos master, and you can query them on port 5050 or 5051, and you can collect a lot of this data. But you may have to query multiple servers across the cluster, and it may not be as complete as in real time as the Mesos DNS service is. So we can see etcds on these ports, and I think we can also find the Kronos port. So let's see what time. Okay, cool. Yeah. What about Mesos DNS? He's probably never heard of it. So how many of you, yeah, these penguins. So, all right, go ahead. There's a story there, but that's not for now.
All right, so it's worth mentioning that with that agent that we currently have on the box, that is inside of the container. So we don't actually have a presence on the underlying host. We're still stuck, kind of stuck inside of the container. But we do have the ability to hit up other network services that are inside of the DCOS cluster, such as etcd. I mentioned before that etcd is a key value store that is used for configuration management across most DCOS clusters. You can basically think of it as an HTTP accessible JSON object. So if I know the name of a key, like a key of a key value pair, I can query etcd for that key and it will give me back the value. Common uses for etcd are things like, where is my database? That key value pair can be stored in etcd. You could also store the database username and password in there. So there's all kinds of stuff that is used by applications stored in etcd to maintain their configuration. If you're familiar with the DevOpsy 12-factor app, which is a set of principles that a DevOps application should adhere to, you put your configuration in your environment variables, and etcd is the DCOS equivalent of your environment variables. So we have built out a...
Press escape first.
Yeah. We've built out an EmPyre module that you can use to crawl through an entire etcd an entire etcd hierarchy and dump all of those potentially sensitive keys and configurations out of the cluster. Okay, so we'll start even from installing etcd. So jumping into the universe, we can find the etcd definition. And install it. Takes about 30 seconds. We had actually pre-installed it for this and had already populated a couple etcd key values into the configuration store. So we're not going to go through the process of putting data into etcd. But once it's up and running, you can use EmPyre.
Sweet ASCII art.
Yep. It's not a hacker tool if it doesn't have ASCII art. We'll look at our current listeners. So we still have that HTTP listener running. See if our agent is still there and active, which it is, and interact with it. So since we don't want to keep track of which our agents are by like 8R, 75, FH, etc., we'll just rename this agent to www. So it's something that we can easily keep track of if and when we eventually add more agents. So we'll then call out a shell command ID, make sure that we still have interactive access onto the agent, set the module, DCOS, etcd crawler, and there's a couple of options in here. Info. So the depth. etcd is hierarchical, so you can nest values as deep as you want. By default, the module will crawl to the uttermost depths of etcd, which if it's a large key store could take a long time. But you can change it, so it'll only go 2 or 3 or however many levels through the tree you want it to go. Same as the other module, you specify the target. Here we're using the Mesos DNS etcd.mesos. FQDN, and then specifying the agent that we're proxying through, as well as the port that etcd is running on. Since we are in a DCOS environment here, we can just leave those all as defaults and run the module. So here we get out a DB host IP and password. From here, we could assume that inside of the container somewhere, the application is probably already aware of the username. So a little bit of digging through the application or the environment variables inside of the container, we'd have everything that we would need to pivot outside of the container to this database hosted outside of the DCOS cluster. Yeah, Voln's ahead, so there's more. We'll keep going.
Thanks, Scott. So, so the big thing with etcd is the containers need a way to store critical information, which often is going to contain additional credentials for other services, probably the stuff you want to protect, like databases or data stores and things like that. So and etcd seems to be the service that more and more applications are building around, because it's really easy to interface with, as opposed to some of the other configuration stores that are pre-existing. So Marathon pretty much, if you want to keep containers running a long time, Marathon's one of the services that's going to exist, right? It's basically like the first thing that gets started up inside of this, ecosystem, and it's there to just ensure the critical components keep running. Sometimes depending on the size of your container or your cluster, you might have multiple instances of Marathon, but you're definitely going to have at least one. So the big thing here is, once we have a pivot point inside a container, we don't even really need root in the container. We just need to be able to talk to services that container can talk to, right? We can go over and talk to the Marathon service and request it to do things which are going to enable us to get root access on the actual hosts inside the environment. So these are the hosts that are actually hosting the containers. So just, I like demos. I think they help you, visualize, how an attacker would actually approach these problems. So we're going to run through this real quick. So we got the one web app where we're able to get remote code execution on. We uploaded a web shell. We then uploaded our ELF binary and kicked that off to get interactive with EmPyre. Now with EmPyre, we're going to be able to use that agent to talk to the Marathon service. So you can see we just have Apache on the container right now. So first thing we want to do is we're going to say, Marathon, what's everything you got going on right now, right? We want to know all the jobs that Marathon is currently tasked to do, which in this demo is not going to be that much, but in production it's probably going to be quite a bit. So the key here is twofold. One, looking through the jobs, you can figure out, what is this currently being used for? Is there anything interesting in there that we should also be targeting? And then, two, as we move forward with the next steps of actually using Marathon to gain root access to servers, if you want to be sneaky, you're going to want to blend your jobs in with existing jobs inside of Marathon so they look very similar, right? No two environments are going to have the exact same list of jobs. So, listing the jobs, analyzing them, and then making something that's very similar will enable you to most likely stay under the radar. A lot of this stuff could be logged, although may not be logged by default, right? So, in fact, not much inside these environments is secure by default. So it's really a matter of you taking the time and effort to research how to secure it and then come in, which we'll talk about later in the presentation. So this is what you get when you query it. You just get a big JSON blob back. So you're pretty much going to have to go through the JSON blob, maybe write like a little Python parser to help extract the data out that you want. Because there's going to be some data in here that you'll be really interested in, and some of the jobs you probably don't care about. So, but once you list all the jobs, then the next step is to create and start a malicious job of your own. So I wrote another module for this to help automate this process. So this is really just abusing your ability to talk to the Marathon API. So just use the module inside of EmPyre, and then this module is called Marathon API Create Start App. And then you can set these variables. So in our case, you can have Marathon as part of a job execute a command. So we're going to take advantage of that to execute a malicious command that will wget our binary, our ELF binary, set it as executable, and then kick it off as root on the server. So that's what I'm doing here. I just have this curl statement. You'll download the file, set it as executable, and then execute it. And then we just execute. Now, if you're paying attention very closely to the parameters that I've been setting in the demo, you will notice that I didn't actually specify which server in the environment that I want this command to be executed on. So as a feature, the way these ecosystems work is they automatically figure out what servers have the least amount of resource utilization on them, and they distribute jobs to them. So there is some additional settings you can do inside of JSON if you wanted to target a specific server. But in this case, we really just want to get root on a box. So any server inside the cluster will do. And if we looked at our net map from the beginning, I think there's about 8 servers total throughout this entire environment. And 6 of them are considered agents. And so one of the 6 will have this command executed on it. So if you go into the GUI, you can actually see the job that we just created, which got executed. And you can actually see if an admin were to go into it, like, hey, what the heck? This is curling something. I didn't really set this job. What's going on here? So we probably want to get rid of that as quick as possible. So as soon as you execute it, you can then make a follow-up API request. And as soon as you're sure you have a root on a box, you can just go in and delete that job. And then the logging may or may not be enabled on the targets. So this is just me going through using the REST API module again, but this time setting the request method to delete, and then using that to remove the job out to kind of make it more stealthy. Okay, great. All right, Marathon. Nobody gets in, nobody gets out. All right, I put the demo on YouTube so you can check it out. And I wrote a blog post that details all the commands and how to replicate all this. So if you want more details, you can definitely go check those out. And I put the link on Twitter if you follow me on Twitter. So you can do the same thing with Kronos. You can interact with the Kronos service. The core difference here is it's going to be listening on a random high port, so you're definitely going to need to figure out what that port is, either via Mesos DNS or via enumerating probably Mesos agents. And then you can tell it to execute on any of the agents inside the cluster as well. But it's pretty much just what we did, so we're going to skip over that demo. All right. Thanks, Scott.
So now that you kind of own the cluster, we went from no access to initial access via a web shell to access with www data within the container to root on one of the agents on the boxes. You can pretty much own the entire cluster there. But in your pen testing engagement, you might be interested in getting targets that are outside of that cluster. So once you have the cluster, where do you go? In the exploration I've done, you're probably going to be able to find something that you can do with the release chain. Code has to end up, or packages have to end up somehow on these servers running inside of the containers. So more likely than not, you're going to find credentials to an internal Git repository, maybe a public Git repository where their code is kept. You may get access to their Docker registries. either one of these could hold information that'll be useful in places elsewhere through the organization, especially Git. You can also crawl through their configuration management. So once you have root on one of their boxes, you can find out what they're using for config management, if it's Salt or Puppet or Ansible or whatever. Find what configuration is being laid down. Sometimes credentials will be laid down, keys may be laid down that enables automation between these boxes and other ones through the environment. Application and database credentials will be pretty common. Kick scripts, cloud init scripts. If you're on an environment that's running in Amazon, with that presence on the host, you can then access the EC2 metadata service. If the EC2 instance is running with a highly privileged role, you can then create temporary credentials and actually log into their, make commands to their AWS API endpoints. So there's a lot of ways that you could go laterally once you have this access. So recommendations. Most of the services that we've talked about today do have authentication available. Most of them do not have authentication enabled by default. If you were to hit up each of these services and frameworks and enable the authentication, most of the time they only support basic auth, so nothing too crazy or great, but it is something that would make getting that further access a little bit more difficult. Not every framework, unfortunately, will support authentication, so you definitely have to be careful when you're going through and trying to turn on off. Next is to get network segmentation in place. Out of the box, DCOS, containers launched through DCOS will use either host networking or bridge networking, which will give those access to anything that the host has access to, network access to. You can try and make your infrastructure application aware. There are vendors that will sell you appliances that will adapt their firewall rules to what is running on what instances, what hosts. There's also frameworks that you can run within DCOS that will dynamically create IP tables rules and set up a BGP overlay. This is Calico. It's a pretty sweet setup, and it lets you pretty easily split out the flows that your containers are communicating with each other on from your management plane. So if Calico had been running here and that network segmentation had been in place, then once we had a presence on side of the container, we wouldn't necessarily have been able to escalate into Mesos and Marathon. Next is update. DCOS is very much an emerging technology. There's new versions coming out every couple of weeks. Very often they include some kinds of security enhancements. So nothing really magic here. Keep yourself safe, enable authentication, get network segmentation in place, and make sure you keep your stuff up to date.
Yeah, and then lastly, just wanted to say thanks to the guys who wrote the EmPyre framework. They spent a lot of time that we built off of to make these DCOS and Mesos modules. So thanks to them. And then big thanks to SAINTCON and the organizers for all that they do and enabling us to have, this great venue to come present this information. So thanks guys for coming out. We appreciate it. So.